Dear friends, welcome to this electrical engineering knowledge sharing channel AMP Power System. We are discussing workshop 9, under which we will be discussing about the UPS system. In the workshop 9, we have already completed one session, that is video number 75, where we have discussed about the basics of UPS system and standalone various type of UPS. We have seen there are three type of standalone UPS. The detail we have discussed. Today we are going to discuss a new session, that is session 2, where we will be discussing about the various configuration we can make or we can arrange the UPS system in various topology. So using this standalone or single UPS system, so that the power requirement in terms of quality, in terms of voltage profile, and in terms of interruption, we can cater for to the various utilities, means various consumers. Now, how we can make this UPS arrangement or this UPS configuration, that we will be discussing in details in this video. Question is why this configuration is required, because we have seen in the case of a standalone UPS, whether it is offline, online or inter-reactive UPS system, there is only one UPS. If that UPS fails, then the quality power is difficult to get. The intention of this UPS configuration is that we will be using multiple, maybe in various occasions multiple UPS, so that uninterrupted good profile voltage and good quality with a low harmonics power supply is available to the various consumers or various loads uninterruptedly. That is the main purpose of this configuration of UPS system. So with the proper configuration, we can make sure that the various loads or the various consumers will get the UPS power supply or good profile, voltage profile and good quality power supply uninterruptedly, whether the UPS gets fail or not. That arrangement, that in case of failure of the UPS, still some UPS shall be available, which will ensure quality power to the consumers. To achieve this goal, we normally do the arrangement of this configuration of the UPS system. So when we are looking the configuration of the UPS system, we divide the configuration, UPS configuration system. There are, if you look into the various books, and there will be so many nomenclature terminologies there. But I have summarized all these various terminology we are in the various books or various documents. By summarizing all these nomenclature, I have divided. I have decided this could be in broadly can be divided into two basic groups. Okay, so on that basic groups we'll be further discussing. So in this video we'll be discussing this configuration system, UPS configuration, in terms of two major groups. One group is a non-distribution UPS system, another is a distribution UPS system. So when we are going to configuration of UPS system configuration, in terms of configuration, which are looking into configuration, we are dividing the UPS system configuration in two categories. One is a non-distribution type of configuration, and second category is a distribution type of configuration, distribution type of redundant this is also non-distribution type of redundant configuration. This is a redundant configuration, or it could be standalone as well. But in the case of distribution type, is a distribution type of redundant configuration. These are the mainly two major categories of UPS system configuration we can make. So we'll try to cover both. We'll be discussing in details of both the option. So let's see how the length it is. If it is getting lengthy, then with this video number 76, we'll discuss about the non-distribution type redundant or standalone UPS system. and the distribution type redundant UPS system will be capturing in the another video. Okay, so this distribution and non-distribution type UPS system is mainly or broadly classified whether the output of the UPS, we have already seen how UPS work. This is, if this is the UPS, and then we have a bypass, right? We have the bypass through the static switch, and then the bypass is coming. We are giving main power supply over here, and this is the output. Okay, and this is our UPS system, which we have already discussed. This system is consisting of converter and inverter. If you look into the UPS system, we have this system is this, there is a AC supply getting converted, then we have a battery, and then we have a inverter. Okay, this is DC, AC is going out, that is the output. So this is this block we have shown over here as a UPS. Okay, and then it has a main supply is coming over here, and it has a bypass. This bypass is what is going output. So this is the single UPS system, the standalone UPS system. Now in case of non-distribution type UPS system, this is a single UPS. Now whether if we go for the redundant or multiple type UPS, in that case instead of single UPS there will be a multiple number of UPS. Whether the UPS output are common, that means this is one UPS, suppose there is another UPS over here. Okay, whether this output and this output getting joined, and then it is going normal to a distribution board or the power supply consumers. If it is, that means there is a common bus. You can say this is a common AC bus. In this bus, both UPS supply is joined. If we make this type of arrangement, that means if there is a single bus, in that case, that distribution is called that is, in that case, the output is not getting distributed. Output is not independent. Both the UPS output is getting common in a single bus. That's why it is called non-distribution type. But if this output of the UPS is not getting joined, if it is independent, this UPS bypass and is coming, this is going to one UPS, one distribution, and then it is going to another distribution. If it is a output is not merged, it is going separately. Okay, in that case, it is called distributed. It is not joined. That is we call distribution type redundant UPS system, that we'll discuss in detail. That means simply non-distribution type UPS means the output of the UPS is joined together and going to a single bus. And but distribution type UPS means output of the, if we use a multiple number of UPS, output of the UPS is independent to each other. They are not joined together, and then it is going to the individual bus or individual load bus or individual load center. Wherever the loads are there, it is going there. If that is the arrangement, then we call it distribution type UPS. In detail further we will discuss in details. Now first let us discuss about the non-distribution type UPS system. If we look into the non-distribution type UPS system, again the non-distribution type UPS system, we can divide it into three different categories. Mainly 3 or 4 different categories you can say. One is a standalone or single UPS system. Okay, first system which we can divide, that is a number one is a, if you go to the non-distribution type UPS system, non-distribution type UPS system, mainly we can divide in three different categories. Number one is a standalone or single UPS system. Single UPS system, that is one, first configuration. Okay, second configuration is a hot standby or redundant. We call it redundant UPS system. That is the second system. Third is a parallel redundant UPS system. Parallel redundant UPS system, that is called 1+1. And then fourth category is the same, parallel redundant UPS system N+1. Okay, these are the mainly. What is this N? N means suppose I need a UPS of 300 kilowatt. Suppose one UPS I need 300 kilowatt. Okay, I have a load of 300 kilowatt load. I have to cater this 300 kilowatt load, or suppose 300 kilowatt means 350 kVA. Suppose this amount of load I have to cater. If we want to cater this load, then how many UPS we are using? There are various alternatives I have. I can use only one UPS of 350 kVA, right? That is I can use. In that case, my load is catered for. Alternatively, I can do another thing. I can use two number UPS of 175 kVA. That also I can use. In that case also I am getting 350 kVA. So this number is called N. That means the total load is whether it is catered by only one UPS or multiple number of UPS. Suppose I am using 7 number UPS of is 50 kVA. 50 kVA, 7 number UPS. So how much it is? That is also 350 kVA. In that case, this N is a 7. This N means how many UPS we are considering just to meet the load demand. The number of UPS we are using to cater or meet the load demand, that number is representing by this N. With this N, how many SPRs or how much standby capacity we are, or redundancy I am considering. If I consider only one redundant, then it is N plus 1. If I consider, suppose I have 7 UPS of 50 kVA for catering the load, and I am consider 2 number of redundant UPS. In that case, it will be N plus 2 system. Okay. So, and in case when I am considering only one UPS, in that case, and one redundant, in that case, what happens? N equal to 1, 1 plus 1, that means this item number 3. So, item number 3 is a special case of item number 4. Item number 3 means parallel redundant UPS system. 1 plus 1, it means here I have only one UPS is required to meet the entire load, and similar rating another UPS I am considered for the redundant. So that is the meaning of parallel redundant UPS. And parallel redundant UPS N plus 1 means N plus 1 or N plus 2 or N plus 3 means that N is the number of UPS I need to cater for the entire load. So these are the mainly 4 category of non-distribution type UPS system. Now how this 4 category will go further, we will discuss further on this, how this configuration are topology, or how this configuration is made, how these are wired up, or how this is connected to each other, that we'll discuss now. Now first is a standalone UPS. Now the standalone UPS means here only one UPS is there. But here we will not be discussing about the offline UPS. We will be discussing about the online UPS. Okay. Online standalone or single UPS system. That is the most simplest form of UPS system. How that system, that standalone system we are discussing first. A standalone online UPS, not the offline. Okay. Online UPS. How that system will work? That is our converter. Then we have the battery. Then we have the inverter. We have already seen all these things. Inverter. And then this is a power supply input. This is going to output. Then we have a static switch. Here is a static switch. And then it is going here. Right. So this is we call is a standalone only single UPS system. Okay. So this block is our UPS. This is our UPS block. Right. That has a converter and the inverter. This is our converter which is converting AC to DC, and this is our inverter which is converting DC to AC. These are these two blocks with the battery we call is UPS system, and this is a static switch. We know that in this case how it is operating. In the case of online UPS, the name is implied. This, so if we draw in a simple form, this is my UPS part, right? UPS and inline, and then I have the bypass. This is the simple form of UPS, right? So in this form, what is happening? Normally main power supply coming over here. This is our main power supply. We are giving over here main power supply, or giving output. And this is our load bus. Here is a various loads are connected. It is through the MCB, it is going to various. Suppose this is MDB. Okay. So various loads are connected over here. So this is a UPS output. In normal condition, what is happening, how this is working? Normal condition, the power supply going through the UPS system, that is converting, it is two-stage conversion. there is a DC converted, then the main power supply is coming, that is converted into AC, DC is converted into AC, and it is catering for the load. The moment this UPS fail, means this inverter fail, suppose this inverter fail, in that case, what will happen? Immediately, the static switch will operate and the main power supply, original power supply will go through this. Now, if we want this, then we have already seen this is a online UPS system. To avoid this, now as we connect into online, what will happen? The moment UPS supply fail, UPS system fail, this converter fail, not the inverter fail, immediately it will be going to bypass. But if the converter fail, in that case, battery will discharge through this. So there are three stage operation. In normal, both the UPS system is healthy, power supply is healthy. In that case, it will have this online UPS thing, standalone will be working. This UPS will be working. This AC converted to DC, DC converted to AC, it will cater power. If for any reason main power supply fail, immediately what will happen? Immediately battery will discharge through the inverter and the load will be maintaining. But if this inverter fail, then what will happen? Then this power supply cannot go through the UPS, then it will switch to a static switch will be on and the main power supply will go and bypass this. So most of the time, 95% time it will be running through the inverter UPS system. Only if in case of failure of the inverter, that may be how much chance? That may be only 2% or 1%. During that time, it will come by the bypass. Now, this we have already discussed. When this comes through the bypass supply, in that case, the bypass supply, these are not the quality supply. It is coming from the grid. So the grid supply, lot of harmonics, all this thing is there, that will come over here. So we will not get a quality power that 2% or 1% time, or 99% or 98% time we will be getting the quality. If the distribution system or this load system over here, if this load is not subjecting or is not sensitive to this non-quality power, then no issue. If it is a sensitive, in that case, what we need to do? We have to put a buck boost transformer, or we have to arrange a ferro resonance transformer in this path. Or that means we have to use a voltage controller, voltage regulator. You have to include here one voltage regulator in this main path. Through the static switch path, the main supply when is coming, we have to use one voltage regulator over here. That voltage regulator, it could be a buck boost transformer, it could be ferro resonance transformer, or it could be any solid state type of regulator we have to use on the bypass path, so that if the load is sensitive, if not, then it will be using. This is a standalone UPS system. So in the case of a standalone UPS system, only one UPS is working, one UPS is connected. Okay. Now, next, if we look into this, another point we need to discuss how to decide, that I will discuss at the end of this discussion. So this is a single standalone UPS system. Second UPS system is a redundant or hot standby UPS system. How that redundant or hot standby UPS system is working? Let us draw that system. Here we use that two UPS system. Okay, it is a hot standby or redundant UPS system. Hot standby or redundant UPS system. Redundant UPS system. What we do over here? We use here two UPS system. Both the UPS system is 100% capacity. Okay, both UPS is a 100% capacity. We use two UPS. How this two UPS? Suppose this is our UPS 1. This is our UPS 1. There are two UPS. Suppose this is our UPS. This is UPS 1. This is UPS 1, and it has a bypass. Okay, this is our bypass. It is a static switch and connected over here. It is going out. This is a main input. For the main supply, it is coming main input. This is a UPS 1. Then we have another UPS 2. Suppose this is our UPS 2. How this UPS 2 is working? This is another UPS, we call it UPS 2. It is also independent UPS, and these UPS, it is also has a main input, okay, main input, and then these UPS and these UPS is connected through a static switch. There is a static switch over here and it is connected over here, okay. These are the two UPS system. Is connected in, these are two, this output is coming over here and it is joined over here. So here, this is a 100, suppose the load, whatever the, how is the load, suppose this is going to a distribution, main DB or power DB, okay. So this is my power DB. This is power DB, how this, there is a bus bar and there is a various feeder. This is MCBs, okay. So these are the various MCBs over here. The load is distributed over here. So this MCB either 3-phase or single phase depending on the UPS. If the UPS is 3-phase, then this is a 3-phase MDB, and if it is a single phase, then it is a single phase DB. That is why. So it is going to this bus direct. Both the UPS supply going to the bus. Okay. Here, these UPS, both the UPS, it is a hot standby, means the UPS running, but it is not connected together. So how it is working? This is one of the option. In that case, the UPS, this static switch is not on, it is off. So UPS 1 is running and UPS 1 is giving power supply to the distribution board. This UPS is 100% capacity, means if the load is 50 kilowatt or suppose 50 kilowatt, then the UPS capacity is also 50 kilowatt. UPS 1 is 50 kilowatt, this is also 50 kilowatt. If the load is 50 kilowatt. If the load is 100 kilowatt or 100 kVA, then both the UPS, this UPS 100 kVA, this UPS 100 kVA. So normally UPS 1 is running and it is catering power to the main DB. Okay. So distribution board is getting very good quality power because it is going through the UPS system, through the converter and inverter. Now, the moment for any reason, if this UPS fail, the moment this UPS fail, immediately the fail signal of the UPS triggered this static switch, and this static switch will be on. Immediately this UPS already running in hot condition, it is hot running condition, but it is not catering any power. Then immediately it will cater power. That is one of the option. Then this static switch will switch on and then catering power. This is one of the option. So most of the time, most of the 99.5% time, I will get a good quality power because in both the option, UPS coming through the power supply is coming through the UPS system. Now, in case both the UPS fail at the same time or for any reason, in that case, what will happen? Then this static switch will be on and the bypass will come to the distribution board. Power supply will be remain uninterrupted, but during this time, the quality power will not be there. That may be very less because if one UPS fail, other UPS is there. So if both UPS fail, that generally not a design consideration. We do not consider that both the UPS will be fail at the same time. So we do not consider this thing. So if that we need to consider, in that case, only that small portion of the percentage time, it will be unquality power will be going, and if we need that also to be quality, then we can put a voltage regulator over here as we said before. Okay. Another point I have not mentioned yet, in addition to this static bypass, we have one maintenance bypass. Yeah, the same supply is coming, or you can take a different supply. It is a maintenance bypass. Okay, there is a manual switch over here, and through this it is connected. This is when it is connected. If we want, suppose this UPS need to remove for maintenance purpose, then what we will do? That is mainly important in the case of single UPS. In that case, if we take out of this UPS, second UPS will cut our supply. But if this single, in case of previous option, that is hot standby not, that is a standalone system, if this UPS fail, then a static switch will take over. But if I want to take this UPS system for maintenance, then what I will do? I can take the static switch or I can take a separate maintenance bypass. So I will close this switch, maintenance bypass, and then I can take out this UPS for the maintenance purpose. That's why when you look into the UPS system, you will see there are two bypass. One is a static bypass, that is for supplying power continuously. Another is a maintenance bypass, that is for the manual interruption. So when we plan way, if we want to maintain any of the UPS, that UPS maintenance bypass will be switched on and the power supply will be going to the maintenance bypass, and the total static switch with including UPS system will be taken out for the maintenance purpose. Okay, that is another bypass is there. So that is it. So these are the redundant, what is stand by a redundant UPS system. The third system, in the case of non-distribution system, third system is what is that? That is our parallel redundant UPS system. In the case of parallel redundant UPS system, we have a one could be 1 plus 1 UPS system. In that case, how it is? This is a first UPS is this. This is one UPS, UPS 1, and then it has a bypass, a static bypass, a static switch. Through the static switch is going to, this is the output. There is a second UPS, UPS 2. Then it is also, this is input, input 1, and this is a input 2. Okay, this is also a power supply is coming and it is connected over here. Okay, and then it is going to the load. Suppose this is the MDB and this MTB have a MCB. These all are MCB. It is going from here. Okay, it is going. These are the MDB part, distribution portion. Here, how it is working, and if you want, there is a maintenance bypass. There is a maintenance bypass you can put over here with a switch. This is a maintenance bypass. Okay, it is a manual switch. Now, how this UPS, in this case, both the UPS is running. In the case of parallel redundant, in the previous case, we have said one UPS running, other UPS is a standby. When this UPS fail, then the static switch over here, there was a static switch in this location in the previous case. The static switch will be on and it will be catering power to the load. But in the case of parallel redundant, the name is very simple. Parallel redundant means both the UPS is running. In the parallel means both UPS 1 and UPS 2 both are running parallelly. Parallel, when they are running parallelly means output of this UPS, output of this, there is a sensation, there is a voltage sensing device that is going to a card which will synchronize this to supply. Okay, there is a synchronizing card. This card will send both the voltage and it will synchronize, then only it will be connected. There is a MCB and all this, there is a breaker over here, that is there. Okay, or contactor will be there, the contactor will be closed when only synchronizing is there. That I am not shown over here. So in that case, in the case of parallel UPS, parallel redundant UPS, both the UPS is 100% capacity. This is 100%, this is 100%. One UPS is enough to cater for the load. But here, another is a redundant UPS, but it is a running UPS. It is also catering the load. Means 100% load, 50% is catered by the UPS 1, 50% catered by this UPS 2. So entire load is shared by both the UPS through the synchronization process, and the output is coming common going to the DB. This is a call 1 plus 1 redundant UPS. Here n equal to or n plus 1, where n is equal to 1. That is the configuration. It is a parallel redundant UPS system. 1 plus 1 means one UPS is enough to cater for the load, and other UPS is a redundant UPS, but it is a running UPS. It is also catering the load. So the load sharing process, this will cater 50%, this will cater 50%, and these will be joined together through the synchronization process. Then it will go to the system. And the moment any of the UPS fail, as the other UPS is 100% capacity, it will cater the load. So there is absolutely no problem to get the quality load uninterruptedly. And for any reason, if both UPS system, total UPS system is down, in that case there is a static bypass that will cater the power to the system. And during maintenance, suppose I want to take out this UPS system for maintenance, I have the other UPS and that will cater for power. And if we want to take both UPS out plant wise, then I have to switch on this maintenance bypass. Okay, or in that case, in both UPS, normally if one of the UPS taken out, then other UPS is working, that will cater for load. If that failed, then the static switch will switch on. So maintenance bypass is not really required, but when we want to maintain any of the UPS system, that system will be taken out. So maintenance bypass will connect, and that will keep as another source. Okay. So these are the parallel redundant. Now if we go to parallel redundant, n value more than 1, in that case that is n plus 1. Suppose I have a 100% load, we plan that 100% load will not cater by the 100% UPS system. We will take 50% capacity UPS system. In that case, suppose I have a 200 kVA load, consider. So we have planned 200 kV load will be catered by 2 UPS. So we have to consider each UPS how much? 100% capacity, 100 kVA. So that is UPS 1 and then UPS 2. UPS 2, both are 100 kVA capacity. This is 100 kVA, this is 100 kVA. Okay. So these two UPS is required to cater for the load. So these are going to the common load. This is a load is over here. This is the input 1, we are giving from one source. This is the input 2, giving from another source. Okay. And then these are the synchronized. This sub output and this output are synchronized going to the load. That is and load is a 200 kVA. Okay. Our configuration n plus 1 configuration. Here n equal to 2. Okay. Now as we need a redundant one, so what we'll put? We'll put another same capacity UPS as a standby. 100 kVA, 100 kVA UPS, that is UPS 3. Okay. That is also connected over here. Okay. That is also connected over here. If we do not want to connect over here, then we have to put a static switch over here. But as we are telling, this is a running UPS, parallel operation UPS. So it will be not through the static switch, it will be connected. Through the synchronization process, all the 3 UPS is running in parallel. Okay, here 2 normal, 1 standby. Okay. Now, and then we have a static switch. This is a static switch we have. And then we have a maintain. If this is coming from the same supply, one static switch, but if it is coming from different, we can put separate static switch over here. Is a separate static switch. And then we have a common maintenance bypass. Now, how it is working now? Now, in normal condition, on the 3 UPS is running, so each is carrying 33% of load sharing. These UPS are sharing load at the rate of 33%. Okay. So each load is a 99% load is scattered by 3 UPS. Now, at the moment one of the UPS fail, then other 2 UPS is enough to cater, then immediately loading will be 50%. Okay, loading will be changed, but power supply will be maintaining. Now, if 2 of the UPS fail, suppose this UPS and this UPS fail, then what will happen in that case? The single UPS cannot cater the load, then immediately load will be transferred to the static switch. Okay, then the corresponding, if the 2 UPS fail at the same time, in that case the respective static switch will operate and the load will be catered by the static switch. Okay, then one of the UPS will be running and the other UPS supply will be taken over by the bypass supply and the bypass will be running the load. So that chance failure of the 2 UPS at one time is very less. But if any of the UPS fail, suppose this UPS fail, then that 2 UPS will be running at 50% load, it will be catering. Suppose this UPS fail, then UPS 1 and UPS 3 will be running in parallel, catering 100% load. If UPS 3 is failed, then UPS 1 and UPS 2 will be catering the load. Now at any time, if suppose UPS 1 and UPS 2 failed simultaneously, then this static switch and this static switch will be on and that will be catering the load. Okay. So this is the way this parallel redundant n plus 1 UPS system work. Okay. These are the 3 configuration we have used. Now consider, now we have to look into more important point. There are various options. Now which option I will follow? What is the guideline? How we will decide the option selection? In the case of non-distribution UPS system, we have seen 3 different configurations. Now which configuration I will use? How we will decide? For that decision, what we do? We generally analyze the various requirement and based on the we analyze the various parameters of the UPS system and based on that parameter and the customer requirement with the load requirement, important what load is required for this power supply. This UPS actually like a generator. It is giving power supply to a system, to a installation. Now that installation, what type of criticality of that installation? Is it very critical installation, or it is very less critical, or it is a more critical, or it is most critical? Critical, more critical, or most critical? We can divide three, because UPS system we use only for the critical loads, right? Only for the critical application. Now the criticality, what degree of criticality? That is important. So if we say normal critical, that is a normal. But if we say it is a more critical, that is another degree high. And if we come most critical, that is the highest degree. Suppose if I divide the degree 1, 5 and 10, 3 stages. 1 means normal critical. Critical loads are critical, but it is normal critical. And degree 2 is a medium critical, means grade 5. Number 5. And if I give a number 10, that means it is a most critical. So depending on that, what type of criticality we have to decide the configuration. Now, to decide the configuration, we analyze the various parameters of the system. So what are the parameters we consider? First, consider when we are going to select any of the configuration, first we have to see that system, that configuration, how much reliable that configuration. That means reliable means, what do you mean by reliable? Reliable means the load should uninterruptedly get the power, and that power should be quality power. It is not the main power supply. We should get the quality power, means proper voltage profile, proper non-harmonics, when a filtered power, we should get uninterruptedly to the system. If we get that power to the system, then we call this system is reliable. Okay, and system will not suddenly fail. System reliable means here how the power supply you are getting reliable power, and the system is not suddenly fail in, even the system in case of failure, I will get uninterrupted power, quality power. That we can say it is a reliable power. Number one, reliability we will measure in by two. One is we get the quality power, and second is power should be uninterrupted to the load. If that the configuration gives us, that we call it reliable. So one of the parameter we measure, we analyze, that is a reliability of the system. When we select any system, first we will check the reliability. What is the reliability of the system? Means this system will give me the uninterrupted quality power or not. That is first part. Second part is the design of the configuration we are making. This design, how complex that design is. That design is a complex design with lot of switching, lot of interface, lot of interconnection, lot of things to be required. That complexity of the design is also we have to evaluate. That is the second, is a design complexity. Complexity we need to evaluate. These are the parameters we evaluate when we are going to select any of the your arrangement, any of these your UPS system configuration. Third parameter we consider how much maintainability. In case of maintenance of the system, how friendly it is. During maintenance, whether its power is getting off or I am getting uninterrupted power. So maintainability also we need to check. Maintainability also we need to check during this evaluation process when we are going to select any of the arrangement. Number 4, what is that? Number 4 is your we have reliability, complexity, maintainability we have checked. Then we need to check about this redundancy. How much redundancy I have? Redundancy in the system. What is the percent of redundancy? I have a 50% redundancy or 100% redundancy or 200% redundancy. That also I need to check. Number 5, we need to check the cost also. How much cost it is? That is also we need to check when we will be designing the system. Okay. Then another point we have to check that functional wise, when it is functioning, how is the function of the system? System function is very friendly. That functionality of the system also we have to check. Functionality of the system also we need to check. These are the 6 parameters. Out of that, 5 is a technical parameter: reliability, complexity, maintainability, redundancy, and functionality. These are the 5 technical parameters we need to check, and then we have to cost, and based on that we have to decide. So how we do that thing? We give every item has a number. Suppose this is a number 5, I am giving 1 to 5. Okay, this 1 to 5 means 1 means is reliability very less. Yeah, if we weight in that way, suppose this number giving is each of this item giving weight 1 to 5. Okay, each, and then we make a table 1 to 5. This is also giving 1 to 5. It is 1 to 5. So 1 to 5, 5 means it is highly 100% reliable. If it is 100% reliable, that means that system get the weight 5. If it is a minimum reliable, then that system will get 1. So this way, these 5 parameter we evaluate. Okay, that evaluation, it is depending on the design team, it may vary slightly, but as per my perception, I have evaluated this thing, and accordingly for this 3 system which we discussed already, for the 3 system we can evaluate these parameters and see how is it. Okay, then we can decide. Now let's come to the first point. If we look into the first point, first system, what is the first system? A standalone system. How is the system? There is only single UPS. We have seen already single UPS, and there is a static bypass. That is a first system we have seen, right? A standalone system. This is UPS 1, and then we have a bypass. It is going over here and power is going here. That is the system we have. In the case of first a standalone system, SS, a standalone system. So if we evaluate this parameter for this standalone system, for the reliability, what is happening? Suppose this UPS system fails, then what will happen? You will not get the quality power over here. The moment UPS system fails, immediately this will go through the bypass, and the bypass is a main supply. The main supply will come over here. If we don't have the voltage control system and the harmonics removal business over here, if we use the normal UPS system, in that case, this moment UPS fail, I don't have the quality power. So reliability is not giving 100% not reliable. That means this output is not always 100% reliable. So if I want to weight this thing, how much I can give? I can give the reliability over here. Suppose 2.5. It is 50% reliable. If it fail any time, then what will happen? This will go through the main power supply, which is not. Now, how we can increase the reliability? If I give a filter unit over here, like a buck boost transformer or your ferroresonance transformer, then the reliability will increase. Maybe it go to 4. I can increase this way by. That means when I want to increase the reliability, I have to increase the cost. Okay, that is the first part. So this is a reliability. Suppose with this simple UPS system, we are considering reliability 2. Now complexity, how is it? It is a single UPS. There is no major switching operation over here. It is simplest in operational form. So in that case, I don't have the complexity in the system. So from the complexity point of view, how much weight I can give? I can give 5. It is the highest, simplest form, means there is no complexity in the system. Maintainability, what is happening? I cannot maintain it. If I want to maintain it, immediately power supply will go out. Though I have a maintenance bypass. I have a maintenance bypass over here, but the moment I close the maintenance bypass and then I take out the UPS, immediately power supply will go to the normal power supply. So it is not giving me the maintenance flexibility to ensure the quality power supply. So maintainability I will give also weight number 2. Then redundancy, here I don't have any redundancy. Only I have a redundancy through the static switch. So here also the redundancy I think I can give 2. Now functionality, it will work very functionally very good because there is no issue of problem. It will give continuously with a very simple form of arrangement. I can get this power supply. Functionality is very good, so I can give a functionality 4. Now the cost wise, it is the lowest cost because I have only one UPS. That cost I have to bear. I don't have the multiple cost, and the cost can slightly. I can increase the cost to increase the reliability. So cost wise, it is a weighting 5. So this is my weight list as per figure. Now with this, now I have to see what type of load I am going this. Suppose I have a load, this single standalone UPS. This is the parameters. Now whether only drawback over here, you see cost wise very cheap, complexity, no complexity, Maintainability, during maintainability, what is happening? This power supply going through the bypass path, that is the redundancy. During the redundancy means if this UPS fail, also it is going through the main supply. Whether the load, the critical load for which I am giving the power supply, that critical load can accept this main power supply voltage variation and the harmonics. The harmonics coming to the main power supply, that power supply will go in case of reliability, maintainability and the redundancy, right? So in this three options, the load which I am catering for, that load, what type of load that is? Now, if the load can take this main power supply without any disturbance and load can operate, then this form is very good. Where is that? Suppose I have a house, or suppose there is an apartment building. In the apartment building, there is a UPS system. That UPS system power supply, what it is doing? It is catering very emergency power inside each apartment. Suppose there is telephone system, printing machine, or laptop or computer is working, this type of things. But those systems, they don't interrupt. They don't want that any interruption to the power. In that case, I don't need a very quality power. Normally quality power, it is come very good. It does not come, but main power supply should available. Availability is important. Power should be available, whether it is a quality UPS power or the main power, that should be uninterruptedly, it should be available. If that is the requirement, I can use this single UPS system. That means in one of the house, a small building or apartment building, a small office, all this area, I can use or a small business where we need the uninterrupted. Suppose I have a cyber cafe where I have a 6-7 terminals which need uninterrupted power supply. So in that case, I can use this type of system. Suppose I have a small office where maybe 50 people are working. They have a telephone system, there is a computer system, there is a server. So this thing need a uninterrupted power supply. So if this is a UPS supply, very good. If the UPS supply is not there, in that case also main supply will work. In that case also I can use this thing. So this type of critical load I can, and the load value is not very high. Suppose load value is maybe 50 kVA or 100 kVA. In that case, a standalone UPS system, I can use it. But suppose I have another arrangement. I have an arrangement where I need the power supply, quality power supply, like where suppose I have a big office where this lot of system is running. This HR department is there. They have a very sensitive data in the system. Suppose it record that when the power supply is going, some of the devices, they have a very sensitive device, or suppose a small medical center, or where this quality power is required, or there is a medium-sized business where they need a complete various data center, data to be monitored, data to be maintained. So if that is the application where this loads to some extent critical and they need an uninterrupted power supply, in that case, what we can go? We can go for the redundant type UPS system. And if the load is suppose 500 below 1 megawatt, if the load is below megawatt and the load is middle sensitive, like a small business, suppose a medium-sized business or medium-sized banking system, then a small bank, their system, then maybe some company, it has suppose 300 people, they have a HR system, they have a payroll system, all these things they have. This type of system, or some medical hospital, or there is a nursing home where they need a good quality uninterrupted power, because they have to do lot of things in this. In that case also we can use this power supply system. So in that case, what will be that configuration? In that case, when we are going a standard redundant UPS system, in that case, what is this? We have a 2 UPS system, right? 2 UPS system, one normal, one standby. That is the what standby. That what standby means, if one of the UPS fail, then I can get the other UPS. So in that case, the reliability will increase. So I can go to the reliability maybe 4. Then complexity, as there are 2 UPS system, then I have a 2 UPS system. That means we have a complexity in the design, because if one of the UPS fail, other UPS switch over. Then the 2 UPS, there is a static switch. We have seen there is a static switch. There is UPS 1 is here, UPS 2 is here, and this is connected through the static switch. And then we have another static switch over here to take this. Then maintenance bypass, this switch operation, this switch off, because this is running but what standby. So the moment this fail, immediately this will be on. or if that is not on, then this standby switch, this will be on so many switching operation. And if both are running parallel, then in that case load sharing is required, synchronization may be required. So this thing slightly, operation will be slightly complex will be there. So these may be reduced to 3. Then maintainability, I have a easy maintainability. If one of the UPS fail, I can remove this thing because other UPS is available. So I have it is giving more maintainability, flexibility. So it may increase to 3. Then redundancy, I have a 1 redundant, so I can get redundancy maybe 4. And then functionality, as there is a 2 units. In that case, I have a slight complicated operation, but functionality, I get a good quality of power and always. So I can maybe functionality will increase to 4 might be, right? And the cost wise, it will be cost more. So now as the cost is more, so that will be negative part. So the cost maybe it will be 3. Okay. So these will be our evaluation on this. Based on that, we will decide. If we go to parallel redundant UPS, in that case, what will happen? It will further reliability will increase further. So maybe reliability I have a 5. In case of n, suppose I have a n plus 1 or n plus 2. Suppose I have n plus 1 reliability. In that case, whatever the number of UPS running, we have 1 standby. So it is not 5, maybe it will be same like before 4. And the complexity will be hard. Here, all these UPS is running in parallel. It is a parallel redundant. So here will be more switching operation will be required. So the complexity will be maybe 2 operation. Maintainability, I have a higher maintainability because I have a standby UPS. So it will be same. Maintainability will be maybe 4. And the redundancy, I have a 1 redundant UPS is there. So it will be same 4. And functionality, as this is the same like before, it has a slide. I will get always a good quality power because this all are running through the UPS. If one of the UPS fails, then other will be there. So this will increase the functionality. Cost wise, it will be more because it is n plus 1 means same like this cost. That means cost will be 3. But if we go n plus 2 parallel operation, suppose n plus 2, I have a suppose n is equal to 3 and I am going to a standby. In that case, the cost will increase, functionality will give a better value, maintainability will give in value, but complexity will increase, reliability will increase. So if this is if the supply is going to a big medium sized data center, very sensitive load data, all this thing, in that case we go generally n plus 2 UPS system in parallel operation, means all will be running on the load sharing mode with the synchronization, and it will go to the same bus. Okay. And in this case, another point is this reliability, the single point fault. So reliability, when we are checking the reliability, we have to see if there is a single fault. In that condition, if the system is going out, then reliability is very poor. Here in the case of a standalone unit, reliability, why I put very low? Because suppose the inverter fails, what will happen? Then I will not get the quality power at all. That any of the single point there is a fault, immediately reliability will go down. So that's why single point fault, in case of single point fault, I am getting power supply or not. That is also decide the reliability. So except a standalone system, in other case, reliability will be high because in case of single point fault, other system is working and that will give the power supply. So these are the 3 different type of non-distribution UPS system. So I hope it is nearly more than 50 minutes. So we need to close it over here. So I could not include the other distribution UPS configuration under this video. So we'll do a separate video number 77. So hope this arrangement and this discussion will be helpful to you all to decide first to decide what type of UPS configuration we will design for a particular client or for a particular installation, that this evaluation and this discussion may help to you design engineers. So please go through this, and same as before, if it is help, that will be my pleasure. And I am closing with this, and next video we will discuss about the distribution system. Maybe next video will be after 10 to 12 days because I am going for a break. I am going to Italy. I'll be back from Italy. After that, I will try to capture the second video, video number 77. Till that time, keep well and go through these videos, and if you have any queries, please put your comments. I'll try to respond. Thank you very much. Thank you.